All right, this is homework 3.1, and I'm trying out a new video system to see if it uploads any better. Please let me know if it does. Today we're looking at homework 3.1, differentiability, and I think I'll work problem number 2. I think that's where a lot of people will have trouble. It says if f of x equals x cubed plus 2x squared when x is less than or equal to 2, and kx squared plus b when x is greater than 2, determine the values of k and b to make the function differentiable everywhere. So this is the key word, and I really hope you are not memorizing problem types where you're like, oh, when you get to a problem like this, you do blank. Instead, you want to look for the keywords and understand what they mean. Differentiable everywhere tells you two things. One, the function is continuous, and two, the function has the limit as x approaches a from the left of f prime of x equal to the limit as x approaches a from the right of f prime of x for all functions, for all values of a. So this is a polynomial and it's continuous everywhere. This is a polynomial and it's continuous everywhere. All we're worried about is where they meet up. So we want to make sure that this function is continuous at x equals 2. And let's remember what continuous means. Continuous tells us that the function value and the limits must be the same. So we need the limit as x approaches 2 from the left of f of x to equal the limit as x approaches 2 from the right of f of x. Because otherwise the function doesn't meet up. We need the two values to actually meet up. We need the limits to meet up so that the function can be continuous, which is part of being differentiable. So the limit as x approaches 2 from the left, we can do by direct substitution. So we plug in 2. 2 cubed is 8. 2 times 2 squared is 8. And that equals, to do the limit as x approaches 2 from the right, we also can use direct substitution. We get 4k plus b, because when x is 2, 2 squared is 4, that's 4k. Now this is an equation with two variables in it. We need a second equation to be able to use substitution or elimination or any of our solving systems of equations methods. So this is where we're going to use that it's differentiable. We need that the derivative as x approaches from the left has to equal the limit as the derivative approaches a from the right. And so in this case, the derivative is equal to 3x squared plus 4x when x is less than 2, and 2xk when, 2xk, no b there anymore, when x is greater than 2. And we need those two limits to be identical to each other. So again, the limit as x approaches 2 of the derivative, we're just going to plug in 2 here. So we get 12 plus 8 has to equal, that's the limit as the derivative approaches 2 from the left, is equal to 4k. So k equals, let's see, we had 20, k is 5. Since k is 5, we can plug in 5 into this value and get 16 equals 20 plus b. b is negative 4. So b is negative 4 and k is 5. All right.